Fructose, an unexpected driver of cancer spread. How a common sugar helps surviving cancer cells loosen their grip and metastasize. Sunday, August 16th, 2026. Recent research has reframed fructose, not just as a dietary sugar, but as an active signaling molecule and metabolic fuel that can promote cancer metastasis. The strongest new evidence comes from studies on ovarian and colorectal cancers, with supporting data across several other tumor types. Here is a clearer picture of what is known so far. The 2026 ovarian cancer discovery. In high-grade serous ovarian cancer, the most common and deadly form, chemotherapy with drugs such as cisplatin kills many cells but leaves others in a senescent, non-dividing state. These zombie cells remain metabolically active and release a mix of signals into their surroundings. A 2026 study published in Nature Aging identified fructose as a key component of that secretome. Senescent cancer cells consume glucose and convert some of it into fructose, which they then release. Neighboring cancer cells take up this fructose and process it, triggering a drop in their own cholesterol production. Cholesterol helps maintain the adhesive properties of cell membranes, the biological glue that keeps tumor cells clustered together. When cholesterol levels fall, cells detach more readily and become more mobile, increasing the chance they will seed new tumors elsewhere in the body. In mouse models, simply exposing ovarian cancer cells to the fluid secreted by senescent cells increased metastatic burden. Adding pure fructose at physiological concentrations reproduced the detachment effect. Blocking the enzymes that cells use to metabolize fructose reduced the spread. Remarkably, a high fructose diet alone also increased metastasis even in the absence of prior chemotherapy. The researchers emphasize that these findings remain preclinical. They have not yet been confirmed in people, and patients should not alter prescribed treatments such as statins on the basis of this work. Colorectal cancer and sugary drinks. A separate 2025 study in Nature Metabolism examined the glucose-fructose combination found in most sugar-sweetened beverages, the mix present in high fructose corn syrup and sucrose. In colorectal cancer models, this combination enhanced cell motility and dramatically increased liver metastasis compared with glucose alone. The mechanism centers on the enzyme sorbitol dehydrogenase, SORD. The sugar mix activates SORD, shifts the cell's redox balance, raising the NAD plus NADH ratio, accelerates glycolysis, and feeds the mevalonate pathway that produces cholesterol and related lipids. The result is greater migratory capacity and metastatic potential. Blocking SORD slowed metastasis even when the sugar mix was present. Earlier work had already shown that colorectal cancer cells that reach the liver upregulate aldolase B, ALDA-B, an enzyme that allows them to exploit local fructose for growth. Restricting dietary fructose or targeting ALDA-B slowed metastatic growth in the liver while leaving primary tumors largely unaffected. Wider patterns across cancers. Fructose appears in multiple metastatic pathways. Breast cancer models show fructose diets driving larger primary tumors and more lung metastases than equivalent glucose or starch diets, partly through inflammatory lipid signaling. Pancreatic, gastric, and other cancers can generate fructose endogenously from glucose via the polyol pathway or take it up via the transporter GLUT5. This supports migration, epithelial to mesenchymal transition, and survival under nutrient stress. Some studies indicate fructose can influence the tumor microenvironment, including pushing macrophages toward a more tumor-promoting state. In many cases, the effect is stronger when glucose and fructose are present together, matching the composition of common sweetened drinks rather than pure fructose or pure glucose. Dietary context and practical considerations. Fructose occurs naturally in fruit, honey, and some vegetables, but the largest modern exposures come from processed foods and beverages sweetened with high fructose corn syrup, or sucrose. Whole fruit delivers fructose alongside fiber, water, and polyphenols, which change absorption and metabolic impact. Liquid sugars from sodas, energy drinks, sweetened coffees, and many nutritional supplements bypass those buffers and deliver rapid, high doses. The preclinical data suggests that high dietary fructose can amplify metastatic potential in certain cancers, especially after chemotherapy or in tumors that have already reached metabolic organs such as the liver. This does not mean fructose causes cancer or that every patient must eliminate all sources. It does support the broader public health advice to limit added sugars, particularly sugary drinks, and it opens research avenues into whether temporary dietary restriction or metabolic inhibitors could reduce recurrence risk in high-risk patients. Open questions and next steps. Key uncertainties remain. How well do the mouse doses and delivery methods translate to typical human consumption? Does the source of fructose, fruit versus processed, matter as much as the absolute amount? Can targeting fructose metabolism or related enzymes, SORD, ALDO-B, ketohexokinase isoforms, become a practical therapeutic strategy without unacceptable side effects? And what is the interaction with commonly prescribed cholesterol-lowering drugs? The emerging picture is that fructose is more than a simple calorie source for tumors. In specific biological contexts, it functions as a metabolic signal that loosens cellular adhesion and fuels the steps required for metastasis. The evidence is strongest in laboratory and animal models of ovarian and colorectal cancer. Human validation and clinical trials will determine whether these insights change patient care. The author has placed this work in the public domain. It may be freely imported, exported, shared, distributed, edited, modified, or reformatted without explicit consent from the author. As a visually impaired person, the author asserts his rights under the Marrakesh Treaty to facilitate access to published works for persons who are blind, visually impaired, or otherwise print disabled. 2013, wipo.int.
Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.